Hello teacher. Today our group have will have a report about lab 2 Lunar lander. Our group have two members, me Nguyễn Thanh Tùng and Nguyễn Đình Dương. And Đình Dương will help me to make the introduction about the lunar lander environment. Okay, can you help me?
Uh, the lunar lander V3's environment simulates a spacecraft landing on the moon. The study is to control the uh, roster main engine, left engine, right engine, so that the lander touches down safely within the target zones. The environment row stack in clouding position, velocity, angle, angular velocity, and less contact. The reverse depend on landing accuracy, fueling efficiency, and avoiding crashes. And As of objective landing safely between two left action space their G displays the military action zero do nothing one left engine two main engine three right engine.
And the next one is the part 2 parameter variation. In this environment, there are 5 parameters we can change. First one is the continuous, which determines whether the environment uses decreased or continuous actions. Parameter 2, gravity. The gravity constant applied to the lander. Default is 10. According to the documentation, value should be between 0 and -12. Enable wind will enable to enable the wind effect. Wind power. If the wind is enabled, this sets the maximum strength of the linear wind applied to the craft. The documentation recommends values in the range of 0 to 20. Turbulence power is the maximum rotational wind noise applied to the graph. The documentation recommends values in the range of 1 to 2. And the next one is the agent comparison. In this report, we have 3 policies. The first policy is the manual policy, which the user will control by the up, down, left, and key on the keyboard. Next one is the heuristic policy. We will control the lander by the observation here. If it's for too fast, it will enable the main engine, and if it like rotate, the engine will rotate back. Then the last one is the random policy. Will choose randomly from one in 4 actions. And the next is the testing. In this environment, we use gravity by 10 minus 10, visible wind, and turbulent power is 2. So faster training will random mode will be none, and we will train about 50 epoch. After 50 epoch, the result average reward is here, and the success rate is 0%. Uh, the next policy is random policy. We have the same setting as the environment below, and after 50 epoch, average reward is here, and success rate is 0%. And the last one is the last one is the manual agent. Okay, we will control the lander by the keyboard. It's a little hard. Okay, touch. Okay, we will stop here, and as you can see, and we move to reflection. Which parameter has the most greatest impact on the difficulty? I think among all the parameters, gravity has the strongest impact on the difficulty of the games, because higher gravity requires more actions to balance the lander to reach the goal. Visible wind makes the game much easier, as the lander can descend straight without being blown sideways. When the gravity parameter increases, the agent must use main engine more frequently to counter the stronger downward pull. When gravity decreases, the lander descends more slowly, requiring fewer corrections. And the final part is conclusion. Đình Dương, can you help me the final part?
Gravity growth to the most influential parameter in the lunar lander environment. Seem high gravity improves the difficulty high, requiring more trust and precise control the active safe landing allow gravity reduce the chance the high allow with smarter distance with food uh, correction. Moreover, airplane wind makes the stack significantly handle as the lander is constantly blown sideways and require more action to stay coolant. Environment setting the correctly safe stack difficulty in lunar lander invents more chance in gravity and bring wind and shift the stack from manageable to very challenging. So safely tuning this parameter is essential for fine validation and training.
Okay, thank you, Đình Dương. And that is the final part of our report. Thank you for listening.